Today we're going to be looking at 3 ways to automate drawings with kBridge. We've got a couple different use cases of kBridge standalone and kBridge in conjunction with CAD features. And today, as always, my partner in crime, Chris DiEllo. I'll hand it over to you for a little intro.
Awesome. Thank you, Holland. And to everyone joining, whether you're watching live with us here or you watch the recording at some point thereafter, we appreciate you taking the time. I think we have some good things to show you, some educational information to share with you today. So simply put, drawings, whether they're parts, assemblies, weldments, connections, whatever installation details and overall and such have or continue to be critical assets for engineer to order companies and their channels, whoever those users are. Those channels might be sales, it could be engineering, production, it might also be end consumers or even dealers or partners or manufacturers reps, something like that. So while technology has certainly allowed for 3D visualization and AR, VR, digital twins, simulation, all those things are awesome. Drawings are still a vital component of ETO companies' process, and again, whatever their deliverables are. So today, in terms of an agenda, we're going to talk through some of the challenges that lacking drawing automation has caused within ETO situations. Then we'll talk through the 3 use cases or demonstrate 3 use cases, I should say, that Holland mentioned. Really, we'll call it kBridge standalone, kBridge with parametric CAD, and then kBridge embedded within AutoCAD. You'll understand how those use cases work and who the users are and what kinds of functions can happen along those. And then ultimately, we'll close out the session with some Q&A.
Yeah, so definitely want to encourage everybody to use the Q&A feature of the webinar to submit questions as we go, and we will address those at the end.
Yeah, good stuff. So I don't know, a question that's burning in my mind anyway is, hey, can a good sales drawing help close a sale? And my knee jerk to this was, well, duh, yes, it can. So I get it that we're stating the obvious here, depending upon the audience, but it's important to acknowledge that the quality of a sales drawing and the speed at which we can then get that to a customer, prospective customer, is incredibly important. I'm guessing you don't disagree, Mr. Dotts.
No, I think it's a great question, and I find it especially interesting. You know, I'm not an engineer. I don't come from an engineering background. I went to art school, but you know, art is an industry of its own. So sometimes the drawing is the sale, if you consider it from that perspective. But I think especially the ability to not just have a drawing, but have a good quality drawing that you're confident in is a real competitive edge if you're going up against competitors who maybe don't have drawings or have lesser quality drawings or take longer to get their drawings. So yes, I feel like this is a pretty easy answer there.
Yeah, good stuff. And I don't want to focus only on sales either, because the benefits, well, I guess the challenges and the benefits go beyond sales. So I guess there are really, I'll call them 5 benefits challenges that we see most often with respect to lacking drawing automation. The first is delays. And that's just, related to sales. It's not being able to respond to your customer fast enough. With respect to manufacturing, now you have fabrication, assembly, production waiting on post-order engineering or drafting to produce some drawing packet or some definition of what the work or the task is going to be. The next is mistakes, just general errors. And so when we talk about automation in general, once you get something locked in and defined, it's going to be repeatable. It's going to be correct. It's going to be error prone. If you find an error, you fix it, and then it doesn't happen again because it's automated. When you have manual drawing creation, it just introduces the potential for errors because I'm doing that each time manually, and I can get distracted easily or whatever. So I could just forget to put something on the drawing. So an omission is as bad as an error, can be as bad as an error. The next is inconsistencies. And that's just because regardless of, if I'm the only one doing drawings, then I can likely be consistent within my ATO organization. But if I have an entire department of draftspersons or engineers doing drawings, then it's very likely that the content on the drawing itself will differ depending upon who creates the drawings and whether that's views or dimensions or the layers that are displayed or the notes that are on it or whatever, or the location of a view or something like that. All those things can change. The fourth is, I'll call it misinterpretation. It's common for ETO companies or companies with variable products to use tabulated drawings. And while that adds to speed of delivery, because I can have these, alpha characters as dimensions, then I have a table that updates or that I update manually, depending upon how that works, that show the numerical values for the tabulated or the alpha characters on the dimensions. And that's fine, other than the fact that depending upon if it's my first time looking at a drawing, I could just misunderstand that. I've seen actually where there are drawings where entire views are just crossed out, or a detail is crossed out, and that doesn't scream of professionalism. Again, maybe it's okay for internal things, but not so great when you point it outwardly. And all these inconsistencies, misinterpretations, again, may not, they may not be as impactful as a customer views something. If views are in different locations, doesn't really matter. But for a manufacturing person, for example, if I know that for my task, I'm going to look in the certain location on a certain drawing sheet every time, if I don't have that view there, or if I don't have that information, I'm going to be slowed down. So we want to avoid that. And that last piece then goes to the resource availability or resources impact. And that's just things we've talked about multiple times in other episodes as it relates to trying to keep engineering focused on product development and order specific tasks that need to be done that are truly value added rather than just supporting sales or sales channels or customers. So automating those things that we can automate ends up being very powerful and yeah, and good stuff here that we're going to get into.
All right. Sounds great. I think we're ready for our first use case. So kBridge is a standalone product. Now, why would a customer or manufacturer want to use kBridge on its own?
Yeah. Boy, well, without taking up the rest of the time of the webinar to talk through all those possible reasons, kind of top handful or top two maybe are, one is because it allows for a number of things on this list here that we'll talk about faster than a traditional CAD system. So, because kBridge is a cloud-based platform, I can use any device, have internet access, and go through the process of visual configuration as we've shown in the past, get real-time drawings in the past. I don't have to worry about CAD. That's one of the biggest things. Now, and that equates to the slowness of CAD automation. It also creates to talk to the usability of CAD. But in general, where we see customers, every ETO company out there has a CAD system in their engineering department. They're going to go through the process of designing their product to designing, just in general products, but also specific solutions based upon their customers' requirements. It's also true that they don't need to have that level of detail, or maybe they don't want to take the time to automate their CAD models and drawings to be further upstream, meaning customer facing, meaning sales channel facing. So using kBridge is an incredibly visually compelling, real-time drawing accessibility, lightweight platform that allows the process of whether it be visual configuration or real-time drawing creation or engineering design automation to happen very easily. So whether I'm responding to customers faster, don't need to wait on engineering and the CAD system. I can that's just for sales drawings. For post-order engineering, well, now I have the ability to actually get manufacturing information more quickly. I don't, and that we won't even get to today, but that could be done actually in a black box. That doesn't even need to be where kBridge is exposed within a UI to a particular user set. It could all be done behind the scenes to create drawing packages or manufacturing information. And I mentioned the disruption engineering in one of the challenges. So, Holland, you brought up a good point earlier. You don't have an engineering background, but I think you know how to spell CAD and you know how to use kBridge. I guess what have you found from maybe those last two bullets there?
I mean, I think it's really what you mentioned as far as the user base. So I think that's the real value add there. kBridge can be configured in a way that it's useful and valuable to somebody that doesn't have any CAD experience. So it can be created with a UI that's simple enough, user friendly to navigate without having to know an in-depth knowledge of how CAD programs work. So I think depending on the use case and who you want to expose that functionality to, I think that's a very important factor there.
Makes good
So
sense.
let's
Yeah.
go ahead and jump into the demo
Exactly.
then.
Yeah. If you want to kind of start up the demo here. So this first use case is kBridge standalone. And what that means is there's no CAD connection at all. The next two use cases we're going to show you, there is a CAD interaction and connection, and we'll explain what that is. This is a concrete vault. So it looks like a cube because it's a cube. We're not trying to show intricate geometry here, but there's a tremendous amount going on here. So where you're starting here is these top and bottom pieces of this concrete vault that'll house pumping equipment or whatever the case is. But there is a drawing here. So Holland, if we hold up here for a second, immediately out of the gate, I don't need to wait. I don't need to send CAD information in order to get a drawing created. You saw how easily Holland toggled between those two tabs, between the vault and the drawings tab on the left-hand side of his screen there, where he can go from the actual 3D model itself, and there are different views that you can look at that, to the drawing itself. So you can press on here, Alan. Thank you for giving me let me talk over there. In this case, there are three drawings that are actually shown because there's a general arrangement, which is the entire concrete vault. And then there is a drawing for each of the top and bottom pieces of the vault. And these individual drawings exist to show more details, whether they be penetrations or openings, the rebar structure within the concrete vault. We're not going to try to educate it on precast structures here, but understand that even though the thing looks like a cube with a hole in it, there's more to it than that. There is substantial engineering that goes on for the type of rebar, the bond that's being calculated here, the bends that need to happen related to the rebar. And as you're going to see as we go through this example, we're going to add penetrations into the vault and add sections to the vault, and you'll see that the drawings update accordingly. So not just the content of the drawings, but additional sheets of the drawings get updated, which again is powerful because as a salesperson, maybe I don't even know, how to do this. So I'm going to, kBridge is smart enough to add those other drawings. And B, as an engineer, I don't need to be bothered with it now. kBridge can do that for me, and I can press on. So this drawing is the bottom piece here. So let's go back and make some changes to this. We'll start with dimensional changes. Maybe we'll change the size of the vault itself here, and then we can, you'll see that update, obviously, and certainly the drawing is doing so in real time. We won't keep flipping back to the drawing. You don't need to see that every step of the way. We'll add a couple of riser sections here, and what's happening here, we've color coded them just to differentiate between the different risers. But again, this is going to impact the drawing. It's going to impact the rebar engineering and so forth. We'll limit it to just a single riser. And then you'll notice here in this view, we're looking at the rebar in the model view here. And again, this is important to understand the thickness of the concrete, the amount of rebar to handle this is going to be submerged, underground to house a pump or other pieces of equipment. So it needs to be structurally sound to make sure it doesn't implode just from the weight of whatever the fill or the soil is and so on. So this rebar calculations is happening. And then there's also, to go through the process, there's also a way, because these vaults are heavy, we need to be able to lift that. So there are different configurations of type of what are called lifters. So we can just put some kind of eye bolts on here that maybe, a backhoe or a crane or something can lift these things up and drop it into the excavated hole and so forth. So from here, let's actually go to change some additional elements here and maybe even add some openings, I guess I'll say, to the vault itself, some additional openings. So we'll change the size of this guy, and then we'll say, yeah, all right, that's a smart move, Holland. Let's show the change of the drawing here. So two things to note here. The lifting lugs that are now evident on the drawing itself are for the general arrangement here for the first view. And then you'll notice that there is actually additional sheets that have been added to the drawings packet itself. So we can, I guess before we get there, we'll talk about just the notes that are included, the calculation that's a weight. So in addition to the engineering rules that are for the rebar, kBridge is doing other elements. So again, even if you need this kind of information, you don't necessarily have to rely on CAD because kBridge has its own geometry engine. It can figure out things like centers of gravity and weight and so forth. I mentioned a little before, there are a different number of sheets here. So kBridge is smart enough to know that because I've added a riser, I now need a riser drawing. So the top piece drawing is actually updated based upon the lifting lugs. And I now have this riser drawing as well as the bottom piece. Yeah, so now let's go ahead and create some penetrations here. You'll see that for the way that this has been set up, we have three different styles: round, rectangle, elliptical penetrations, and some also terminators. So those are where you might pass piping or conduit for wiring through and so on. So we can grab maybe a round penetration, a round opening, and pull it onto the model itself. So we can put it in distinct spots. They're targets for where you can put this. You'll notice, maybe it's a little hard to see on the right-hand side there, but there's a modal that pops up and allows you to change the size of the opening. But then we have this interactive aspect of visual configuration where we can really relocate this. So it's something we call active dimensioning, whether I can drag a location or literally key in a value to locate the opening here. And this is done with an opening, but it could be with any feature that is within a kBridge model. So we've located that within the bottom portion of the vault itself. Let's go ahead and grab maybe a rectangle and put it in the riser. And we can certainly relocate that. We'll change that guy, make it a little bigger, maybe 30 by 30. And then again, we can choose to reposition it accordingly. Looks good. And then finally, let's grab a terminator and place that as well. And maybe on the D side, we'll put that guy. Marvelous. And that again looks like at least Holland on my screen anyway, your screen's a little cut off. Don't change anything. I'm just giving you a heads up that their modal to configure the terminators is probably obscured for some of the audience. So where are we now? Okay, we have a model. Great. We've made some updates to it. Really now it's going to come down to what does the drawing look like? How has that changed? We can look at the model, make sure it's what we need, but the thing that we're talking about today is drawing automation. So maybe before we go to drawing automation, we'll take a look at the rebar pieces. So part of the engineering that's going on with kBridge here is that the rebar is smart enough to know, you'll notice that it's not encroaching on any of the openings. So it's configured itself around the opening to make sure the opening is structurally sound, but it's also done all the calculations for that. if we jump back to the drawing, and let's pause here for a moment on the drawing itself, and really the again, part of the intelligence, part of the advantage of drawing automation is that regardless of how the model or the configuration changes, the drawing gets updated. So what's most visually obvious is where we only had a top view or plan view and an elevation before, because there were no openings around the perimeter of the vault. That's all we needed. We just needed those two views and the isometric that fully described what the vault looked like. Well, now, because we've added openings on three sides, now we have an increased number of the elevations to show not only what type of opening or penetration there is, but also its location, its size, where it is on the actual vault, and so forth. So that again becomes powerful, because as a salesperson, I didn't need to go through the process of remembering to add those additional views in. As an engineer, I didn't need to remember to do that. kBridge handles it automatically for us. So from here we can look at a number of different things. And this goes a little bit than these next pieces here around scale and dimension, being able to move dimensions. This becomes powerful because one of the challenges around drawing automation is dimensional overlap, as well as views colliding with one another. It's just challenging to build drawing automation so it handles every possible permutation existing within the automation. So giving people, non-CAD experts, no offense, Holland, but like yourself, the ability to manually adjust things in terms of scale just allows them to create a clear picture without having to understand how to operate a CAD system. Gives people a clear picture, or the ability for him to give a clear picture to his customer. In addition, I'll call it dimension cleanup. It's kind of an arbitrary term, but really, if we zoom into this top view here and look at the dimensions themselves, these are nice and clean because this is an overly complex drawing. But should a drawing gets more complex and you want to relocate a dimension, as you can see what Holland's doing here, it actually allows you to go through the process to relocate the dimensions. And that ends up being just very powerful, because now, again, as a non-CAD person, I can go in and very simply grab some things and move them around. I'm not impacting the design. I can't edit the numerical values here, right? It's just allowing me to do that cleanup. You'll notice that not only do we have additional drawings as we did before and views, but now we're showing the view of the wall B side that actually has that rectangular opening. The bill of material has changed substantially in the upper right-hand corner of the drawing, because we're actually now having additional rebar required, and different lengths and different bend types, and all those things are incorporated into the rebar cut list here. And so there are other drawings that we'll just hammer through here quickly. The riser drawing itself, that again isn't largely all that exciting. We knew it was added earlier on, and then we have the bottom drawing as well, that again shows the opening that's been created here. So yeah, so I guess at this point, really, maybe we look back to the model itself, and I don't know, anything else here, Holland, we want to highlight? I guess really maybe it's worth summarizing
covers it
here.
pretty well.
Yeah, yeah. So I guess again, the question was, can a sales drawing impact these, or I'm sorry, why would I use kBridge standalone? It kind of comes away with the fact that, hey, depending upon the use case, depending upon the type of deliverable you're creating, especially for sales drawings, although for really complex engineering drawings, we have many customers that do that as well. But for sales drawing, speed, accuracy, high quality drawings, you can't beat it. The traditional CAD automation just doesn't get there. No offense, we work with CAD systems all the time. They have their purpose, and we're going to talk through those in a moment here. But creating these types of drawings and doing the engineering designs that we've shown here, yeah, kBridge standalone is a great way to go.
That's great, and accessibility too.
Accessibility for sure, yes, sir.
All right. Well, let's check out our second use case. So kBridge and parametric CAD. Now, for any non-engineers that may be joining, like myself, can you give us a quick 101 on parametric CAD?
I could try to. Might be only a 100, not 101, but so I guess traditionally I'd always thought of CAD, either in 2D or 3D, and then 3D had different flavors to it, so to speak, solid modeling and whatnot. But parametric CAD is really CAD that can be driven. Well, two things, I guess. It can be parameterized. There are features of it or dimensional values, whatever, that you can define as parameters, and then it can be driven from an external system, let's say, by those parameters. That external system could be a homegrown program. It could be a system like kBridge, but ultimately, you're defining parameters within a CAD system that can then be automated because you're feeding values to those parameters. I mean, there are even CAD systems that will, you can through, VB or something like that, or some native, Creo had something back in the day called Pro Program. You could manually pull up a viewer and key in a number of values and have the CAD system automate itself. So it's really driving those parameters. So hopefully that helps a little bit there.
Who does?
Yeah, this use case is a little bit different. So really where the first use case, kBridge standalone, was, I'll call it omni-channel, really, whether I'm an end user who might be looking to buy that vault, or I'm a salesperson looking to sell that vault, or I'm an engineer looking to further design that vault. I can use kBridge standalone for any of those scenarios. The next two really are, I'll call them engineer specific. So it's a different type of use case. You're not going to have what we're about to show here. You're not going to have a salesperson in all likelihood, or a sales channel use this approach. Excuse me. But the benefits here are that there's a bridge, so to speak. The first example we're going to show will start in kBridge, and we can take the automation that happens within kBridge for an assembly of, we're going to use a mobile cart as the example, kind of a table that's on wheels. And for that, I can configure it visually. I can get sales drawings and so forth on it, not to the level of detail of manufacturing, but I can do all that. However, once that's completed, we can then reference that configuration from inside of SolidWorks or Inventor and actually use the parameters we just talked about to drive the rebuilding of the SolidWorks or Inventor model and the subsequent drawings and automate that whole process. What that equates to is you're really leveraging the kBridge automation that's been built that is predominantly used upstream. Now you're leveraging it through the rest of the enterprise for the purpose of really post-order engineering and manufacturing. As a reference to post-order engineering, if we're talking about engineer-to-order companies, it's not always that every gazinta or widget or special need or requirement that a customer has is going to be anticipated or predictable. So automation is absolutely awesome, but you can't account for every possible once in a blue moon situation that's going to come up. So it's typical that you will have some level of post-order engineering work that needs to be done. So how do we jumpstart that? Well, we actually suck in those parameters into SolidWorks or Inventor, for example, rebuild the model to that configured state. That gets you whatever, 75, 95% of the way there. And then an engineer can actually do the special design work that needs to be done that, again, there would be no way for automation to predict or be ready for. Another thing that we won't get too deep into this, but I anticipate having future episodes on this, is related to the lack of the need of a master model being required. So what does that mean? For folks that have familiarity with traditional CAD systems and going through the process of traditional automation, many times you need to build this kind of super model that's got all the features, all the combinations, all the possible assembly pieces already done, and then you write logic therein to hide, to remove features and or components within an assembly. And that's just not how the automation we're going to show you works. It's the approach that kBridge takes with these parametric CAD systems is a generative approach. So start with an empty assembly simply and pull things in. Why does that matter? Because it's faster and it doesn't require the upfront work to be done to figure out and build that super model, as I've called it. And then finally here, I guess a benefit is that we actually have a pre-built integration for both SolidWorks and Inventor. So what does that mean? And some other Revit that are, specific to kind of the architectural engineering construction world. But the point to be made here is that as kBridge has new releases, as SolidWorks and Inventor have new releases and so forth, that we keep current with those. So that was a lot of hand waving, Holland. So we probably should get into showing what the heck we're going to show.
Let's do it.
So what you're looking at here, again, I mentioned this mobile table. It's not mobile at the moment, but it will be. This demonstration is the combination of kBridge and Autodesk's Inventor. Again, Inventor is akin to the likes of Creo from PTC or SolidWorks from Dassault or NX from Siemens and on and on and on. So the way this operates is just an example. And so this was actually put together by a partner of ours in Germany. So hence why you're going to see German language in the user interface of both kBridge and Inventor. And you'll see, the units of measure are going to be millimeters and so on. So just a heads up there. Don't get too confused at what Farwagen is. I think it means table, but I'm not sure. Maybe cart. Long way to say, what you're looking at here is kBridge. Very simplified model. And it allows me to go through the process of changing dimensional values, configuring this table from a stationary table, changing the size, the legs, and so forth. And so really where we want to take this is go through the configuration process as a salesperson might do, or a dealer, distributor, whatever the case is. And again, simple example here, but we're not trying to show kBridge functionality here. We're really looking toward how we impact Inventor. So if I go to the drawing, just like we saw with the concrete vault, the drawing is going to update as I make dimensional changes, as I turn on and off features or capabilities or whatever components exist within the configuration itself. And then ultimately, I'm going to come to a point where the configured state of what I have is correct. So Holland, maybe hold up for just a second here, please. What you're looking at here is something that an end user of kBridge wouldn't likely see. This is the authoring screen inside of kBridge. So this is where rules are actually built and where you define everything from geometry to parent-child relationships to constraints of models and so forth, and just engineering rules and the parameters that will ultimately be passed over to Inventor in this example. Thanks, Holland. You can keep going here. I just wanted to orient people to what we're seeing here. So we're going to start off by saying, okay, we want to save essentially the configuration that we've built here. And the reason we're saving this is because we're then going to now go through the process of opening Inventor. And while we're in Inventor here, we're going to log in to kBridge. So making that connection to kBridge. And then we'll go ahead and search and select the configuration that we created. And that's just so we know what parameters, what models, and so forth to go in. Note also that in the lower right-hand corner there, we've actually ticked the boxes that say we want to create the drawings and we want to see on screen what's happening in Inventor. So there's going to be some things happening as I talk here that, again, at the end of the day, don't really matter other than the fact that Inventor is going through assembling in the right components, sizing them appropriately, and so on. In the upper right side here, and I'm not going to get too far into the details. Some of this is Autodesk Inventor specific. SolidWorks has its own flavor for these things, but those are the new files that are being created. So in general, there's this idea of templates and members. So the idea of templates in Inventor, they're called factory files. That's where you define all the parameters that you want to be able to handle and so forth. So Holland, why don't you hold up here if you could, please? Thank you. And so the idea here is that members are instances. So the files that's just populated in File Explorer on the right-hand side of Holland's screen there are instances of the template files that are specific to this configuration. So why is this beneficial? Well, because I can, as an engineer, an inventor, for example, I can define this factory file that is a template that has the one-to-many parameters I want controlled. That factory file or template can handle nearly countless configurations. So I only need to create that one for it. And then depending upon the parameters that come from kBridge, those are read into and flex the factory file or that template accordingly, and ultimately instantiate the file or create an instance of that file. The same is true for drawings. So as Holland is continuing the automation here, we're seeing that the part drawings, that little tool holder bracket that goes on the cart, was being created both in its unbent and bent state. We're also seeing that we have the cart itself in terms of a general assembly drawing that's being created on the fly. So there are a number of things, again, that I only did this automation inside of kBridge. I didn't have to redo it inside of Inventor, other than having these template files and making sure that these things are connected. It becomes incredibly powerful for what we're looking at in terms of the drawing automation. So looking at the back of the model here, we can zoom out a bit and talk about the level of detail. And many times people or engineer to order type companies are just overwhelmed by what it takes to automate all the possible permutations and combinations of things. And so if we look at this whole set here, and quite literally the level of detail herein, there are a number of different ways that this can be handled. And really kBridge provides the best of both worlds. And so you can put all these pieces of information into kBridge and make sure that these whole sets, along with their depth, whether they're counter bore, counter sink, their thread pitch, on and on and on, are defined within kBridge. Alternatively, it might be a situation where you don't anticipate this. This whole set is specific to one customer, and therefore you never even asked any questions up front in kBridge, or you didn't allow for the user within kBridge to define this whole set or the details therein. And so this whole set might be created through manual that kind of jumpstart parse, where we configure this table to 95%, and now we're going to go in and manually adjust the properties or the values themselves of the whole set. Yeah, so hopefully that makes sense. Does that make sense, Holland, as I'm kind of hand waving again?
I think it does. I think I have some questions about this, but I want to be mindful of the time. I know we have a whole other use case to get through and Q&A too, so I feel like we should keep moving and
Fair enough.
circle
Yeah, I'm
back in the
probably yammering
Q&A.
on too much. Yeah, fire away, buddy. Yeah. So I guess where we are with this is, and I think we can even look at the bracket on the end here and the punches that go in and so on. It's just more of the same. It's, you can allow kBridge to define these, or they can be done as post-order engineering work, depending upon how predictable and how much those types of things are anticipated. So if we're talking to the engineer to order world, again, we want to automate everything we can automate, but at the same time, we also want to be able to handle things that are in the one-offs, which happens consistently in ATO. Drawings, we're here to talk about drawings. So all these drawings were automatically generated again through the kBridge automation that's created, whether it's the flat pattern file and then the bent state bracket themselves, or the entire general assembly for the table. Yeah. So perhaps without further
Perfect.
ado,
Use case number 3. All right. So we just looked at kBridge as a step in the process. And now with this use case, we're going to be looking at kBridge embedded within. So can you speak a little bit about this particular use case and the benefits of embedding it within an existing workflow.
Yeah, absolutely. Um, eh, Succinctly put, it's similar to, I guess, the parametric CAD and kBridge combination. You're still talking about a use case of engineers in all of the code. Although you could argue that I might be a designer of a reseller. So I'm not the OEM, but I'm a designer that designs entire systems. I'm going to use some of the OEM's components, as well as some other components that I purchase or fabricate myself to create a design. But the difference is we're not using kBridge kind of upstream and then feeding CAD. In this case, we're actually using kBridge embedded within AutoCAD. So the advantage for people that kind of live and breathe within AutoCAD is they don't have to change their workflow. They're going to sit in the same application. They're merely going to reference kBridge and then leverage the UI that kBridge brings and the design intelligence that kBridge brings and the drawing automation that it offers. Why is that beneficial? It's beneficial really because, again, many companies are overwhelmed when it comes to going through the process of configuration. And that is because it, it if they can't use a traditional CPQ tool or they can't use traditional CAD automation because they need to have all their products in that. This example, the first example we're going to show you of the two we're going to show, is a great way to get faster time to value, leveraging the kBridge automation in more of an agile approach, kind of small wins as you go. I'll explain when we get there. And enhancing that partner experience, that's where, again, I might be the reseller of an OEM's product, but I might have my own products. Now I can join the two together. I can design a flow of something or an arrangement of a solution within my AutoCAD system. So again, I'm yammering on too much, sir. Why don't we show the first example here? And that is a material handling example. So it's a conveyor, essentially. Simple example. We're going to go through the process of actually logging into kBridge. Again, that makes the connection. Then we're going to search for and select a project, which is essentially a configurator inside of kBridge. And then we'll actually search for and select a configuration, a specific model type of, in this case, a conveyor. So we're sitting within AutoCAD here. We've pulled up a conveyor at one element or one component of a conveyor material handling system, and kind of these white dialogues that you see around the top and left hand and right hand side of the screen is the kBridge or a version of the kBridge user interface. So now it's like using kBridge inside of AutoCAD. So now I'm literally creating a 3D drawing here as I go through the process. And I have the advantage of actually then selecting other components and quite literally building them together. So could I have done this all in kBridge? Certainly. What's the advantage of doing it here? Well, one advantage is that by selecting the configuration, and you can keep going here, Holland, please. Just again, I realize I'm talking too much. But one aspect of this is that maybe I maybe I have pieces of equipment that aren't in kBridge. So I'm doing this in Autodesk or AutoCAD rather, because I might have static blocks that I can use to represent equipment so that when I'm actually assembling this conveyor scenario or path together, I can leverage the advantage of kBridge, which lets me snap these things together and uses rules around that. But I can also go and grab that other component that kBridge might not even know about and pull that in. And in this case, if I'm that dealer, I'm using the OEM's kBridge essentially configurator to do this, but at the same time, I can grab my own equipment. And on the right-hand side of the screen here, you're also going to notice that this is actually kBridge inside of AutoCAD. So it's smart enough to know that if I flip the 90-degree conveyor component around 180 degrees, it's going to know that it's now going to be a left hand instead of a right hand, or a right hand instead of a left hand. So again, not a largely complex model, but that is the first of the two use cases we'll show you here in terms of kBridge being embedded in AutoCAD. The second is related to a piping layout. And where we'll start here is actually by pulling up this, I'll call it a simplified site plan here. And there are references to non-kBridge things like a pump station in a building in the left and right-hand side of the Holland screen here. The magenta lines are actually the piping path. So now we need to actually figure out, okay, what pipe goes along this path? For this example, we're going to pull up kBridge, which is what's happening here on the left-hand side of the screen, and we're going to reference a quote that was done outside of kBridge. So we're just calling out to an external system using our API to do so. We're pulling in what I'll call the as sold bill of material. So in this example, the salespeople, they do a takeoff on what was done and come up with an as sold bill of material. Now an application engineer goes into Autodesk or AutoCAD, which is where we are. In this case, they're going to select the different fittings and the pipes and place them on the magenta lines of that path. So they selected a Y here. They selected 3 different points on the path. Then the actual component or the fitting there fits. I can go in and actually select the pipe, it says, and there's an additional intelligence here that I'm going to select, okay, from the 2 endpoints of where I want the pipes to run, and kBridge is smart enough to know how many pieces of full-length pipe can be placed to accommodate that distance. And then again, I can, whether I'm going to go in and put in a partial piece there or whatever the case is, I have that design capability. kBridge is also going through the process of putting part numbers to these and prefixes on these and so on. So there's a number of things going on. But we're here to talk about drawings, so let's get to the drawing. So we can put this kind of border or this boundary around where we're going to take for the drawing. And we've actually been looking at this in 2 dimensions, but it is 3D. So think of this, this site plan that I mentioned as being something that's maybe already approved by, what's the right word? Like a Board of Health or a Department of Public Works. So I know I can go along this path, and here's the 3D part. Thanks, Holland, for showing that. And that lets me look at that and understand what that is. And now I can create drawings of the pipe pieces that we've created so far, inclusive of section drawings. So that might be important, again, depending upon where I am or what I need to show to gain ultimate approval. These drawings can be used for everything from engineering to installation. Even the way this is set up is for the sequence of pipe, the order in which you would actually install them. So there are a number of things that happen here. Holland's adding a section view here to show just from a different view what we need to show. We can change everything from scale, of course, to the right viewpoints and decide what content is shown in each drawing. And then here are the drawings that are created. And then ultimately, we're going through the process, or we can actually obscure information on the drawing. And that's just purely, maybe I can turn off layers. We can turn off dimensions if they don't make sense, or part numbers or something like that. But yeah, so I guess I've talked a bunch, and we could probably get to some Q&A if anybody has any, or anybody, a couple minutes over here on the,
yeah. Let's go ahead and let's jump to the transformative value.
good stuff.
So please go ahead.
Yeah, good stuff. So we presented 5 challenge at the beginning of the presentation today. And so this is just a side-by-side comparison of what benefits are there, what is the value there? So rather than having delays, you end up with speed. Rather than having mistakes, you end up with accuracy. Rather than having inconsistencies, you end up being confident. You have something that's repeatable and predictable, and therefore instills confidence. And instead of having being or allowing for misinterpretations, you truly get clarity because you can define what the automation does, and you can make sure that it's repeatable and so on. And then the resource impact is really the increasing of capacity, and that becomes phenomenal because, part of the reason we're doing all these episodes in this webinar series is because we're talking about engineering to order at scale. And if you can't add capacity, you're probably not going to be able to scale very well.
All right. Well, I know we're at time already, but the Q&A session was promised. I have not seen any questions come through, but I have a couple of my own. So
fire away.
We can stay on for a bit longer. I want to go back to example number 2, basically. And when we were when we were zoomed in and looking at the whole set, and there's various screws and mounting types that can be selected, it's a level of granularity that was not present in the kBridge model. So I guess my question is how would a customer try to determine what to bake into kBridge and have accessible in that UI versus maintain access in their CAD program that kBridge is linked and works along with?
Yeah, I'm tracking with you, Holland, and I'll certainly let Scott Heide, who's been nice enough to join us here, add to this. The succinct answer is it's going to be whatever the customer wants to allow. You know, if they want to allow, or if they know that that whole set, for example, or a feature is asked for often and they see it as a competitive advantage, they're going to offer it as a feature. They can actually go through the process of exposing that question and answer, perhaps, or that ability to configure what those whole sets that could be prompted by, do you want a whole set or not? You know, if yes, then okay, now we're going to ask you a bunch more questions. It also might be just that it's depending upon to whom they're exposing kBridge, they might not want to expose a certain, it's a competitive advantage to hold things closer to the vest. So maybe they're not exposing that level of detail to the user. But Scott, any thoughts around Holland's question?
Yeah, so generally you want enough detail that it looks good for sales purposes in kBridge and to generate any drawings that you need to generate. But you don't need all the manufacturing detail there, and may not even want it there, because that detail may slow the model down a little bit, or it may expose some IP about your product that you don't really want to share with the public. And so it's really just a decision on your part how much detail you want to put there. But the general rule of thumb is, only as much as you need. If you can get away with not showing a bunch of stuff inside the model, because no one's going to care, don't model that in kBridge and don't show it in kBridge. But if you need it, it's can be put there, no problem.
Yeah, thank you.
Mm-hmm. So I guess for the purposes of the drawing, it's to essentially kBridge to streamline what's required to make the sale.
Yeah. Yep.
Perfect. Well, I'm not seeing any other questions come in.
We have
I
a
know if
shy
we wanted
audience.
to talk about any of the other, I know there were some details about other integrations or specific software. I know we're already over time a bit, so however you guys want to handle it.
It's a little bit out of left field, but I see a lot of names on the attendee list here, people I know and are familiar with kBridge to some degree already. And you may not know, but now Parasolid is actually built under kBridge. We have the full capability to do solid modeling operations and everything that a solid modeling system can do right in kBridge, real time, fast, on the internet, to support, like Holland was saying, the visualization for sales, or to support the drawings. It helps support the hidden line removal, but it also helps with a lot of the other aspects of creating an accurate and compelling drawing. So this is new in the last couple of months and pretty exciting for us, and we may even have another webinar on that. But it's relevant to some of the things we're talking about today, and pretty cool.
Yeah, appreciate you adding that, Scott. Smart thing. Yeah, and some of these are we're kind of brushing the surface of the cold air on the iceberg that's pretty deep, and we're happy to go deep, but maybe not today.
Sounds great.
Cool.
Well, thanks so much, everybody, for joining us. As usual, we'll send a follow-up email with the link to the recording and keep you posted when we decide on our dates for the next episode of the series. So thanks so much, and appreciate you joining.
Chris.
Thanks, Colin. Thanks, Scott. Guys. Thanks, everyone. Have a good one.